Hey guys, and welcome back. Today we're going to be talking about an introduction to mechanical engineering, power systems, and sources. So, power sources. Mechanical engineers create machines that transmit power using one of two types of power systems: mechanical power systems and fluid power systems. Both mechanical and fluid power systems are examples of technological systems that include the inputs, processes, and outputs. Mechanical power systems transmit power through direct connection with mechanical components. Components such as shafts connected to gears, pulleys, wheels provide rotary motion. Bearings transfer energy from shafts to wheels. Bearings reduce friction with shafts, and they allow controlled movement to shaft to output connection. Mechanical power systems use a number of components, including gears, pulleys, and belts, to transmit power. In the design of mechanical power systems, mechanical engineers rely on principles of simple machines and mechanical control devices. The use of these components allow engineers to design machines that can change the amount or direction of force and the type of output motion, such as the use of pulleys. Mechanical power systems have a wide range of uses. The most fundamental is the engine. An engine that powers a vehicle is an example of a number of mechanisms working together to transmit power. They have potential energy stored in the fuel and battery. Starting a car converts to kinetic energy. Internal combustion engine convert fuel to kinetic energy. Then you have the clutches, gears, belts, and pulleys that all work together in the final design. Fluid power systems transmit power by using the power of confined fluids. These systems are often used in industrial situations that can generate a large amount of force. Fluid power systems generally have fewer moving parts and are easier to manipulate than mechanical power systems. Fluid power is a reliable, efficient, safe, and accurate method of power transmission. There are two main types of fluid power systems. They are categorized by fluid used within them. Hydraulic systems use a liquid such as water or oil to transmit power, and pneumatic systems use air instead of fluid to transmit power. You can find hydraulic and pneumatic power systems in automobile brakes and airplane landing gears, farm and construction equipment, production lines, hand tools, space equipment, and even in amusement park rides. There are advantages and specific uses for both hydraulic and pneumatic power. In fluid power systems, fluid lines are used to transmit the fluid through the system. Common fluid lines are pipes, tubes, and hoses. The types of lines used are carefully selected depending on the type of fluid. The amount of pressure, the system temperature, and other factors all come into play. Depending on these factors, the system may use rigid steel pipes, copper or plastic tubing, or a combination of synthetic and rubber hoses. Each material and type of line has specific advantages and disadvantages that must be considered. The flow of the fluid is controlled by valves. Valves can be used to control either the rate of direction of the fluid flow. Valves that control the rate of flow operate by either closing or restricting the path of fluid. A common example of a flow control valve is a water spigot that allows water to flow into a garden hose. The goal of any power system is to produce usable motion. The usable motion can be any of the 6 types of motion described earlier, but is often either rotary or linear. In fluid power systems, actuators convert fluid power into either linear or rotary motion. When linear motion is desired outcome of a fluid power system, actuators known as cylinders are used. Cylinders are devices that use the pressure of fluid to move a piston that is connected to a rod. The simplest cylinder is a single acting cylinder. These have one port for the fluid to flow in and out. Once the piston and rod are extended, there must be a second force that retracts the cylinder. In other devices, like a hydraulic jack, the weight of the object or gravity is used to retract the cylinder. In situations that need a more controlled or forceful return of a cylinder, a double-acting cylinder is used. Double-acting cylinders have 2 fluid ports, one on each side of the piston. Fluid enters one port to extend the rod and the other port to retract the rod. Hydraulics is common on heavy machinery, construction, and farm equipment. For example, they often rely on hydraulic power to operate devices and in many cases to move vehicles. In construction, machines such as loaders use hydraulic power for both linear and rotary motion. Hydraulic cylinders are used to provide the force required to lift buckets with loads of soil. In a backhoe and its attachments, several cylinders are used to generate articulate movement, much like the human arm, as the backhoe is a third-class lever. An example of a pneumatic system is in air brakes on large trucks. Large vehicles use fluid power braking systems because of the large amount of force they can provide. In an air brake system, the vehicle's engine is connected to an air compressor by a pulley. The compressor sends air into large storage tanks, one for each wheel. The driver's foot pedal is a control valve, and when it's activated, the compressed air from the storage tank engages a cylinder at each end of the brakes. Through mechanical linkages, a cylinder transmits its power into a braking force. The proper application of mechanical principles and tools is critical when designing mechanical systems, so analysis is needed to select the best way to accomplish tasks. The goal of mechanical engineers is to make work easier. To determine if work is made easier or to plan and develop machines, engineers use mathematical calculations of many principles to compare benefits of specific designs and to identify potential disadvantages of designs. As previously discussed, the concept of force and work are critical to understanding of how engineers measure and design mechanical systems. Pressure is fundamental to understanding fluid power. Another important concept is power. Think of the last vehicle you rode in. Do you know how much power it has? Torque is the measure of how much force is acting on an object that causes that object to rotate. Torque is usually measured in foot-pounds and can be used to determine the rotational power of a machine. Mechanical engineers must direct the correct amount of speed and torque in rotating parts in a mechanical system. Gear sets are one way of converting the rotational speed of an input shaft to a different speed of a rotational output shaft. A gear ratio is the ratio of speed, angular velocity, and the input shaft to the output shaft. We will go over in more detail about gear ratios in another video. And finally, mechanical engineers are concerned with designing the most efficient machines possible. To do this, engineers use a formula that investigates the relationship between the ideal mechanical advantage, IMA, and the actual mechanical advantage, which is AMA. So starting off with work equals force divided by distance. In fluid power systems, we calculate work by using pressure and volume of fluid, which is displaced. Displaced volume equals area multiplied by length. In a fluid power system, work is calculated by pressure and the volume of the fluid that is displaced. The formula is W equals P by displaced volume. This displaced volume of a cylinder is calculated by multiplying the area of the piston and the length that it moves. The entire formula reads as W equals P times A area times L length. For example, imagine you have a cylinder with a piston surface of 4 inches squared that can travel 10 inches in a system that can deliver 25 pounds per square inch of pressure. The formula for that would be first calculate V. So V equals area times length. To calculate that, we're going to take our 4 inches squared times 10 inches, and we're going to come out with 40 inches to the third. The second step in this example is calculating work equals pressure times volume. And so we know that our volume is 40 inches to the third, and we know that our work is 25 pounds. So the formula is going to be work equals 25 pounds inches squared times 40 inches to the third, which equals 1,000 inch-pounds of work. Pressure. Pressure is the amount of force acting on each unit of surface area. It's calculated by dividing amount of force by the surface area. Pascal's law, pressure equals force divided by area. The principles of pressure can be seen in simple examples of a hydraulic jack. A hydraulic jack is 2 cylinders connected together. As the handle of the jack is depressed, fluid is pumped out of the input cylinder and into the output cylinder. The input cylinder is much smaller than the output cylinder, In this example, we want to imagine that the input cylinder is 2 inches squared and the output cylinder is 4 inches squared. As you pump the handle of the jack, the 150 pounds of force that are noted in the picture here exerted in the input cylinder. To find the pressure, divide the force by the size of the input cylinder. For example, 150 pounds of force divided by 2 inches squared equals 75 psi. The pressure of 75 psi is then transferred to the other piston. To calculate the force, you're going to multiply the pressure by the size of the output. So in this example, you're taking 75 psi times 4 inches squared equals 300 pounds of force pressure. Power is the rate at which work is performed. We measure power using the formula of power equals work divided by time in seconds. Power can be measured in both mechanical and fluid power systems. For example, imagine you move a 500-pound refrigerator 10 feet in 20 seconds. The formula is P equals W over T. So 500 pounds times 10 feet is calculating for work divided by 20 seconds. So P equals 5,000 foot-pounds divided by 20. The answer is P equals 250 foot-pounds. So in fluid power systems, for a cylinder that applies 800 inch-pounds of work in 2 seconds, the power would be 400 inch-pounds per second. You would take the 800 divided by 2 to get the 400 inch-pounds per second. In devices that generate large amounts of power, horsepower is used to measure the amount of power. To calculate horsepower, we use the formula horsepower equals work divided by time in minutes times 33,000. We can use horsepower to measure the power produced by various systems. You can even calculate your own horsepower using this formula. Imagine there is a 200-pound box that you need to move 25 feet. Assume it took you 2 minutes to move it. We would use our formula HP equals 200 pounds times 25, and then you're going to take 2 minutes times 33,000, convert it down. HP equals 5,000 foot-pounds divided by 66,000 minutes. HP equals 0.075 horsepower. Torque is the measure of how much force acting on an object causes the object to rotate. Torque is usually measured in foot-pounds and can be used to determine the rotational power of a machine. In a mechanical system, torque is calculated by multiplying the distance from the center of the rotation by the amount of weight moved by the motion. Thus, the formula is torque equals force times radius. For example, torque is used when you turn a nut with a wrench. If you're using a wrench that is 1 foot long, radius of the motion, and you use 60 pounds of force, you would generate 60 pounds of torque. Torque can also be used to determine the rotational horsepower of a machine. To calculate horsepower, you must know the revolutions per minute of a machine. The formula rotary mechanical power is horsepower equals force times radius times RPMs divided by 5252. In the previous example of using a wrench that generates 60 pounds of torque, if you were to turn the wrench 10 times per minute, you would generate 0.114 horsepower. We would take our rotational horsepower equals torques times RPM divided by 5252, multiply the 60 times 10, rotational horsepower equals 60 divided by 5252, and we're going to get 0.114. Torque can also be used in fluid power systems. In that example, we would use torque equals pressure times displacement divided by 2 pi. In this example here, we have 3,500 psi times 5 inches to the third divided by 2 pi equals 2785 inch-pounds. Finally, mechanical engineers are concerned with designing the most efficient machines possible. To do this, engineers use a formula that investigates the relationship between the ideal mechanical advantage, IMA, and the actual mechanical advantage, which is AMA. You can see here, load divided by ideal effort equals IMA, and load divided by actual effort is AMA. Please look over these examples and ask your teacher if you have any questions. So, mechanical engineering applications, using the principles that we've talked about so far, you can calculate gearbox ratios. You can calculate how air brakes work, the amount of pressure that you need in your pneumatic systems. Backhoes, which use both pneumatic and compression systems, as well as automobiles. I hope you guys enjoyed this video. If you have any questions, please let me know. I'll talk to you later.